Hey guys, in this video, we're going to discuss Leetcode 562, where we need to find the longest line of consecutive ones in the matrix, and we can move in four directions, either horizontally or vertically or diagonal and anti-diagonal. So basically for this problem, we can use a dynamic program to solve it. And since we can move in four directions, so we have to do dynamic programming four times, one for each direction. So basically for dynamic programming, we can just initialize a grid with zeros or ones, like with dp, ij, all of them are all of them are zeros. And then we can loop through the grid. And every time we have a cell with a value of one, then what we can do is like for horizontal dynamic programming, the current value would be the previous column plus one. Because like if previous column we already have a length of two, then since we have a one pair, then the current length will be 2 plus 1 will be 3. And for same for vertical wise, the value will be the previous row plus 1. And then for diagonal wise, will be previous diagonal plus 1. And then for anti-diagonal, it will be the previous anti-diagonal plus 1. Okay, so let's try to code it out. So first of all, we need to initialize a dp grid since we move in four directions, right? So we can initialize the dp grid with every cell has a array of array of four values and one for each direction. So basically, we can initialize the dp as below. So the dp would be the 0 times 4. So this is one for each direction, and then we have to have the grid of size of the same size of the matrix. So basically, like let's say rows equals to the length of the grid, map columns equal to the length of the first row. All right. So now then we need to do like have it for the columns first. So for I in range columns to be the every column. Okay. This will be every row, sorry. And then we're gonna have adding the rows for j in range of rows. Then we can initialize this matrix. So this will be our initial matrix for the DP grid. All right. So now let's loop through the matrix for I in range rows and the j in range columns for j in range columns. And every time when we encounter a cell of value of 1, so if I and the j is 1, then we can do dp for 4 times, right? So since we initialize every item has a size of 4, so the first one will be horizontal, second one will be vertical, and the third one will be diagonal, and the last one will be anti-diagonal. So let's just do all of them one by one. So horizontal wise, we just copy them up. So let's just do so for horizontal wise, the dp will be the previous one plus 1. All right, so it'll be the first item will be the row dp, right? And also we need to consider an edge case where like if we are on the first column, so there is no previous row, right? So like only if j is larger than 1, else it will be just initialize it to 1. Now we need to do the column wise. So the second item will be the column. And the same, we need to like if you are on the first row, then there will be no previous column. So if I is larger than 0. Sorry, it's larger than, else it will be initialize it to 1. Same for diagonal. So the third item will be the diagonal. And also, like if we are on the if we are on like if we are on the second row and the second column, otherwise there's no diagonal. If I is larger than 0 and the j is larger than 0, else will be none. Same for the last one, the anti-diagonal. So it will be the third item, last item. So it will be if I is larger than 1 and the j will be less than the last column. Less than, yeah, else will be 1. So okay, so now like we are solving this order for all the 4 directions, and we can set a value of the returned value. Let's initialize it to 0. Now we just to, for each one, we just need to, the output will be the maximum of the output and the 4 dp values. Go to the maximum of the output and then the 4 dp values. Yeah, we can just do xdp equal to x. So let's just find the maximum value, and we can just return the response. Okay, so let's see how it goes. Oh, okay, so there's a case failing. Let's see what's wrong here. Expected 9. Okay, so it might be something wrong in one of the edge cases. I 0 0 1 1 2 2 3 3. Okay, so I j minus 1. If j is larger than 0, if I is larger than 0. Oh, here, sorry, my bad. It should be a j plus 1. This is anti-diagonal. Yep, so let's try and run and see. Okay, now it looks good. All right, so for space-wise, we are having a space of rows times columns, which is like we have a dp grid. And for time-wise, it will be row times columns as well. So because we loop through every item one time. All right, so this is the end of the video, and I'll see you guys in the next one.